Hello! In this tutorial, we will go over how to perform stats in Python. First half of the video will be about the functions you will use. Second half of the video will be a tutorial of using these functions. You can review the basics of stats in this video before continuing. Data frame from the pandas library is used to put data into a table where you can perform stats easily. The describe function can be used to get a summary of the stats of a data set. Now, the mean function is used to get the mean or average value. Now, the median function returns the median of a set. Knowing the mean and the median can tell you if the data has a normal distribution or not. Now, the mode function returns values that come up the most in a set or column. Max returns the highest value in a set, while the min returns the min value in a set. Now, to get the quartiles of a set, use the function quantile with 0, 0.25, 0.5, 0.75, or 1 as the value in the parentheses to set which quartile you will want to see. Keep in mind, 0 quartile is the max. The 100th quartile is the max, and the 0.5, or also called the second quartile, is the median. Now, the var function returns the value for variance of a set. This helps you understand the spread of the data. The function standard deviation is used to get the standard deviation, another way to see the spread of the data. Now, the skew functions checks the skew of the data. This helps you understand if the data has a normal distribution or not. The curt function tells you the data kurtosis. This tells you how much data is in the median versus the outer edge. We have a website that offers projects you can do to boost your resume and get experience with certain data skills. Check out SlapJax in the link below to learn more.
Hello guys, I will go over how to calculate some basic statistics in Python. The dataset I use for this example is linked below in the comment section of the SlapJax website. To start off, I will import NumPy, pandas, and matplotlib.pyplot. These are the aliases I'm going to use for them. Just a little short text. I'm going to use the read Excel function from pandas to load the data in. Make sure you upload this data before you run this function, otherwise it will not work. Okay, so you can see here, this is the data set that I loaded into Python. It has it's product ID, product weight, product sport, product storage size, product category, and product price. Looks like it's for a sports brand or sports clothing brand, equipment brand, and you can ignore this first column. Cool. So to get the average of the columns or categories, use the mean function to produce a list of averages for each category. So when I run this function right here, I will get a list of each. If I ignore these first two, kind of product ID, just an ID, and this is just a set, just the indexes. But these give me the averages for the data set. So the average weight is this number, average storage size is this number, and average price is this number right here. Cool. You can also do it for just a single column. So let's say I just only want to get the average weight of a product. I can just attach it here, and then I will get the average weight. And this is called subsetting. So I would just, brackets, and I use the name here, product weight, place that name here, and that will give me the average for that column. And let's say I want to use this number for any functions I create myself or any other things I want to calculate. I can put that number inside of a variable, and now I can use this variable here for anything I need to use, like any functions I want to create or anything I want to calculate. Like let's say I want to calculate the average of this year minus the average from last year, stuff like that. I can use this variable to do these kind of things. Next, I'm going to calculate the median. To get the median, aka the middle value, and to get the mode, aka the most appearing value, we do the same thing as the mean. So we grab median and mode and just attach it at the end of data, and this gives us the medians for each category or each column. And then for the mode, if you look at it, it's the first row. So if I ignore these two, product ID and then the indexes, so the mode is 220, so this value pops with the most in weight, or the most common weight that we see Most common categorical is baseball, and most common size we see is 49. Most common category is gym equipment, and most common price we see is 30.34. So these values pop up the most in the entire data set. So data that is normally distributed has a median and average that are on top or near each other. The median also tends to resist changing its position if outliers and skewness is present, but the mean is more affected by skewness and outliers. So keep that in mind when you're calculating these things. Okay, so to get the range, it's pretty much you would take the highest value minus the lowest value. Right now, I'm going to focus on columns now versus the entire data set. So let's say I want to get the range of the weight. So I'll take the max weight using the max function, which will give me the max value, and then the minimum value of a weight in that column will give me that value subtracted by each other. And I put in a variable, and that variable tells me that the range is 200. So it's a range from 200. Now, quartiles. The quartiles can give an idea of how the data values vary. The first quartile is the point where 25% of the values are less than it. The second quartile is the median, aka the middle number. And the third quartile is the point of 75% of where the data is less than it. So using the quantile function, not quartile, I know it's a little confusing. If you look, I call it the quartile list, but the function is called quantile. And I put the 25, that's the first one, 50, that's the second one, and 75, that's the third quartile. Okay, now I put it in the list right here by putting brackets at the end, and then commas in between each function. So there's 3 functions inside of here and 2 commas separating them. So it gives me a list of 3 functions. And then when I run that, I get this list of the quantiles. So 50, 120, and 200. So that means 25% of the data is less than 50. The median is 120, and then 75% of the data is less than 200 essentially. So less than that number value. And a box plot normally shows these values visually very, very, very well. That's a lot of varies. Sorry about that. So another quick way to get all these statistics are pretty much is running the describe function. And if you ignore these two, or you can also subset just to focus on, the actual like categoricals for the columns. You can just subset it using double brackets, put the names, these 3 names inside here, and then put describe at the end. Same thing as just doing with data, just removes these two to get the pretty much to count how many values are inside, the whole data set essentially. So it's 100, 100, which means there's no missing values. And then the mean for each one, the standard deviation, the minimum value, the first quartile, second quartile, third quartile, and the maximum value. Cool. The variance shows a value that gives an idea of how spread apart the values are. You can find it using the var function. So this function right here, I'm going to subset again, and this gives me the variance for those 3 columns essentially. And this tells me how wide the data is amongst each column. So product price has a very low variation, and product weight has a high variation. Or sorry, not very. Well, yes, I'm correct. Yes. So now to find the skewness of data, you can run the skew function, and to find the kurtosis of a data, you can run the kurt function. The value being more than 1 tells you that the distribution of your data is skewed if you're running the skew function, and the closer to 0 the value is, it tells you that the data does not have skewness, or like how little skewness it has, meaning that the data is normally distributed. And being normally distributed is important to know for statistics because you know what tests you can run on the data set, because there are tests that require the data to be normally distributed and tests that assume the data is not normally distributed. So this is what normal distribution is used for mostly. It also gives an idea of the shape of the data and stuff like that. So if I run this skew function, it tells me this number, and as you can see, they're less than 1. So this tells me that the values within these, if I were to graph them, there's very little skewness, which means the data is very normal. So I can run any tests that have a assumption that there is normality within the data set. And then if I run kurt, This tells me how sharp the data is essentially. But what that really means is that like the middle value, which is the average or median, is very, very, very high compared to the max and the minimum. Like it's tremendously above those. So that value being 1 tells you, okay, there's kurtosis, can't say that properly. English is hard. In the data set. So that tells me that if I were to graph this, there'd be a very sharp peak. And if, closer to 0 means the data is more flat. And yeah, there's not that much kurtosis, which means, the average isn't too far from the median, the minimum or the maximum. So yes. And as you can see here, negative just means it kind of dips down a little bit actually below. But there is actually some kurtosis in this data set, as you can see, because the fact that it's greater than, well, it's -1, but it's just in a negative direction, so it's going down versus up. So that means the peak would be below the x-axis or going towards the bottom. And this tells me that there is kurtosis. So that that means the averages in all 3 of these is pretty far from the minimum and maximum within the columns. So yeah. If you have any questions, please reach out to SlapJax and check out some of our other videos to learn statistics and data science or how to get a job in the data field. Thank you for watching.